good morning everybody, and welcome again to our course on mechanical micro machining processes. In the class we have seen that there are a lot of differences between the CNC machine and the precision micro milling machines. So what we are looking just behind me, it is a purely mechanical micro machining center, and there are a lot of differences that we will see here. So here first thing is that when you do machining at micro scale, what we need is we need high precision and the high resolution. So for this machine, resolution is 0.1 micron, so that you can move x, y or z axis in a step of a 0.1 micron, that is 100 nanometer. And when we are looking about the precision, that means how much you can go near to the exact value. So that is around 0.5 plus or minus micron, 0.5 micron plus or minus, that is the position accuracy of this machine. And we have also seen that there are different type of materials available for construction of the material, construction of the machine for base. Here this is mostly used for the polymer concrete, and we know that polymer concrete has very high properties in terms of the damping efficiency as well as the other things such as like that moisture content retention or those things. These are very less. So here you can get the high rigidity of the machine as well as the very high damping coefficient, so that vibration will be diminished very quickly and it will not propagate into the machines. So what we are looking at here is the one polymer PMMA material is workpiece is fixed with the fixture, and there is a probe attached with the spindle. So this probe is used for measurement of the different dimensions of the workpiece, such as flatness. If it is a circular component, then we can do measurement of the diameter also as well as radius. If it is other than circular, such as square or the rectangular, then we can find the edges also. If you see the other thing which is black color located here, it is a laser based tool measurement system. So here up to 30 micron of diameter of the micro end mill cutter, you can do measurement in terms of length and diameter. And this particular probe what we are looking, it is a non-contact probe. It has an infrared sensor located just above that thing, so you don't need any type of wires connected with this. So advantages of this machine, that once the component is fixed inside, you can do all this measurement in terms of the workpiece measurement as well as the tool measurement without touching the surface. So that is what we need, that we want to avoid the touching of the workpiece when it is in operation, because it is very gentle machining and we don't want to create any type of defects on the surface as well as the misalignment. So this is all the things about the machine. And our research scholar Mr. Shravan Kumar, he will explain you about this machine, that how you can do measurement of the workpiece dimension and how you can do measurement of the tool diameter and tool length in a next session. Thank you very much.
Hi, I am Shravan Kumar, research scholar in Mechanical Engineering Department, working with Professor Soumitra Paul and Professor Shankadev. I am working in the field of mechanical micro machining, and this is the CAN Evo CNC Micro Machining Center. This is a 5-axis micro machining center. It can move linearly in 3 axes, X, Y and Z, and has rotation in 2 axes. Today we will see the machining of a circular workpiece. First we will see the positioning of the workpiece. We will measure the surface. We will check whether the surface is flat or not, and then we will start the machining process. This is our workpiece mounted on the work holding device, a vise, and this is our touch probe. This touch probe is connected to the machine with an infrared receiver. This touch probe can measure the dimensions of the workpiece. It can test the flatness of the workpiece. Since we are dealing with very precise dimensions, we are using a touch probe to measure the exact dimensions required. So now we will see the surface of this workpiece, the surface coordinates, whether the surface is flat or not. So the Z position of the surface is given on the screen. By taking this as the datum, we can proceed with the machining. To check the flatness, we can move to another position. Then once again we can check the surface. Now we can also measure the radius of the workpiece by using the x and y coordinates. So the radius is displayed on the screen once the measurement is done. So once the coordinates of the machine are workpiece are measured, we can proceed to the machining. Once coordinates of the surface of the workpiece are measured, we can proceed with the machining. We can accurately set the required depth using the measured coordinates. So now I will call the tool. This is an end milling cutter. We can measure the length and the diameter of the tool using a precision laser system. This black one is the laser measurement system. Once the measurement is done, the length and radius values are automatically entered into the machine table for the respective tool. For this tool, the length has been measured as 50.65 mm and the radius has been measured as 0.79 mm.
Okay, channel X direction or Y direction? Focused on this workpiece. Focus. इतना पास हो सके.
Now we can proceed to the machining. Machining has been done. It is completed.